All right, more chain rule examples. First, let's look at the function. I'm using the name h for a lot of these, but actually, you'll start to see these presented to you as f. So let's use f. Okay. F of x is secant of x. I mentioned what the derivative of the secant of x function is in a previous video, and I mentioned that you can figure that out using the quotient rule. You can also figure that out using the chain rule. So first of all, secant of x is 1 divided by cosine of x. It's a fraction, so quotient rule could work. But let's view that as cosine of x to the power -1. That would be like the reciprocal of the cosine. Okay, this is not the same as cosine inverse. We're going to get to inverse functions later. This is the reciprocal. That's why I put it on the outside like that. In this example, our outer function, f of u, and should we call it f? Maybe we should call it... maybe we shouldn't even do it that way. Maybe we should do it a little more freeform like I was doing the others. So let's say we want to figure out what our derivative is now. Okay, let's just go ahead and dive in. Our outer function is this u to the -1. If I want to do the derivative of that, by the way, it's derivative with respect to u, okay? The derivative of that would be negative u to the -2, right? So that's the first thing we're going to do. Negative u to the power -2, except in place of u, I will put the inner function, g of x, which in this case is cosine of x here. Then the derivative with respect to x of that part is our negative sine function. So that's what we're going to multiply by next. So times negative sine of x. So there we go. This part right here this is like the derivative of y with respect to u, and this part here is your derivative of u with respect to x. And I hope that goes okay. Now that doesn't look at all like the answer that I told you would get. Back when I was introducing the derivatives of the trig functions, I told you the derivative of secant is secant times tangent. So what gives, right? Well, first of all, the negatives are going to cancel out. We have a negative from here and a negative from here, so those are canceled and those are gone. And then let's put this cosine x squared in the denominator like it's supposed to be, because it's a -2. So that would give us sine of x over cosine squared. Now we can split that up. We can pull out 1 over cosine of x. So that's one of our cosines, and then the other cosine we'll leave underneath the sine. And then this is secant, and this is tangent. So it actually was the same as the answer that I told you we were going to get. It just didn't look that way at first. It needed a little bit of simplification. All right, so do another example. What happens, what would you get if you wanted to do the derivative of the sine of x squared times cosine of x? Okay, let's think about that. So it's a composition. We have some functions plugged into a sine function. So first of all, we should do the derivative of this outer function, the sine function. That's cosine. And we're going to leave the inner functions alone, like you do. But then what we should do is multiply by the derivative of that inner function. Now that seems like something that's kind of hard to do, so I'm not going to try to do it all in one step. Let's just write the derivative of x squared times cosine x. Okay, like that. Now this actually is a product. So what we should do is use the product rule. So for our next one, everything we've already done is still there. But what we're multiplying by here, this is going to be, we're going to apply the product rule. So we're going to do the derivative of you can think of this as like our u and our v. And remember, uv is going to be u prime v plus u v prime. That's our product rule. So we're going to take the derivative of u, which is 2x, and multiply by the original v, cosine of x, and then plus the original u, which is x squared, times the derivative of the v, which is cosine. Derivative is going to be negative sine, like that. So this is like, in the process of doing the chain rule, one of the derivatives that we were called upon to do was actually the derivative of a product, so we had to apply the product rule in the middle of the chain rule. This type of thing can happen a lot when you're doing derivatives of more complex functions, complicated functions. You end up having to like sort of mix rules together and like just follow your nose and just kind of be like, all right, well, now I have to do the derivative of this thing, and this thing is a quotient, so I should use the quotient rule. And then part of that might be a composition, so when I get to that part, I need to use the chain rule, and so on. Okay, so just be ready to use rules when appropriate, in the midst, like, and sort of combining them together in this way. All right, so just a heads up on that.